So welcome. Thanks everybody for joining us today. My name is Julie Pampuch, and I'm a principal at WB in charge of marketing and communications. And we're here today to talk about a topic with a lot of visibility these days because of things like the federal infrastructure plan and because of people like Elon Musk. We're here to talk about electric vehicles and the charging infrastructure that's needed to make this transition from gas-powered to electric possible. So I have a great job here today. I get to introduce you to two of our experts, our top experts in EVs, and then I get to moderate our conversation. So we sent out some pre-event promotional material with resumes for DJ and Bart, but I just wanted to highlight a couple of things in the introduction. So Bart started with our team in 2009. He's a principal, he's a team leader. His clients see him as a trusted advisor because he asks great questions and he makes complex information easy to understand. He is a mechanical engineer by training, and one thing that gives him a little added expertise here today is that he drives a Tesla. So, and then DJ Abate, he started with our team in 2012. He's an associate director of electrical engineering. One of the things that makes him great at what he does is that he thinks beyond just the engineering systems and he thinks about our clients' business drivers. DJ leads the team that manages all of our EV projects, and so that includes about 3,500 charging stations. So a lot of experience here, and we look forward to hearing about that. So our format today is Q&A. I'm going to ask some questions. We'll hear from Bart and DJ. If you have questions, you can put those in the chat. I'll be monitoring that. And then at the end of the presentation, we're going to open up for questions as well. We'll unmute everybody and we'll open this up. So I want to start by just setting the stage a little bit for our conversation. And if this is the first time that you've joined one of our webinars, WB is an MEP technology and commissioning engineering firm. And we work on a wide range of projects with specific expertise in life science, mission critical, healthy, smart, sustainable buildings, energy projects, and of course, infrastructure. So we did our first electric vehicle project in 2017. And since then, we've designed over 3,500 of them in 270 cities, 25 states, 2 countries. So like I said, a lot of experience, a lot of stories, a lot of things that we've learned along the way. So then I just wanted to give a little bit of background on this real exponential growth of electric vehicles. And so a lot of information on here. I just wanted to point out a couple of things. So December 2010 was when the Nissan Leaf was introduced in the US. And I don't know if anybody knows this car, but I just recently saw one. So that was kind of fun, a cute little car. But that was 2010 that was introduced. And then within 10 years, we saw the growth go to 1.74 electric vehicles on the road. According to Bloomberg, by 2027, it's going to be cheaper to make an electric vehicle than a gas-powered one. And then by 2050, the goal in the US is that we will only produce electric vehicles. And so that'll mean that by that time, about 40% of the cars on the road are going to be electric. So rapid growth here. And what that growth means is that we need the infrastructure, the charging infrastructure to support all of those cars. So let's get to our first question. Let's hear from Bart on this one. So I know that there's been a lot of press recently about the infrastructure plan, and it includes a lot of money for electric vehicles. So what do you see as some of the highlights of the plan?
Yeah, so as you mentioned, it has been a very fluid process. It does sound like they're getting down close to the final answer. Right now, they are looking at, and I think it may have passed the House at this point, is $7.5 billion investment to fund the nationwide car charging network. The goal is 500,000 charging stations. The original number was 15 billion. I think the end goal is still the same, but the amount of money that's going to be allocated per year to get there from the federal government is going to be a little bit different. So that $7.5 billion is going to get distributed primarily down to the states, and then the states will manage their own grant programs to distribute those to people who apply for incentive programs. Similar, I think, to the way a lot of the incentive programs are done now, just with a larger pool of money for everybody. So, you know, we're still tracking it, and we'll continue to track it, and we're going to keep an eye on where the money is going. But that's where we're looking at right now.
So let's talk a little bit about the electric vehicles themselves. And Bart and DJ, I'd like to hear from both of you on what you think are some of the advantages and the impacts.
So I can start off with some of the pluses and minuses from my end. You know, just straight looking at energy, not even thinking about where the energy source is. You know, an electric engine is, or electric motor is going to be significantly more efficient. So an internal combustion engine, they're only average about 20% efficiency between the calories that are in the gasoline that actually make it to power on the road. And the best of them are only 37% efficient. And that's the best of the best that I think is coming out of Toyota right now. On the flip side, a high efficiency electric motor is over 90% efficient. So right off the bat, it's easy to see a lot less energy going in to get the same miles on the road. Then kind of taking a little bit of a holistic approach, you know, we're not burning gas anymore at the car. So it's great for air pollution issues, stinky garages, idling cars. All of those things are a positive thing. There's still the grid, and we are still burning fossil fuels to make a lot of our electricity. But obviously there are plans underway to change that, and you know, we can only control what we can control. So probably the biggest downside on the environmental side is going to be the batteries themselves. So, you know, a lithium battery, you know, they require extensive mining and processing of rare earth metals, you know, big strip mining operations. And then at the end of this, you know, it all needs to be disposed of afterward. You can recycle batteries, but those processes are really not perfect. So there's a lot of work to do on that side of things. You know, there's university researchers and, you know, big corporations who are pumping a lot of money into battery development. And those, you know, numbers are all trending in the right direction. So, you know, we'll focus on what we can focus on, let them focus on what they can focus on. And hopefully we'll all converge in another 10 years with the right answer. And then the other thing I wanted to touch on was a question that we get asked regularly, which is, you know, the potentials to the grid, potential impacts to the grid overall. And the answer is that there really aren't any. Most recent studies that we've read indicate that there may actually be a net benefit to the way that the grid actually operates, because most of the charging is going to happen at night. You're going to raise the trough and flatten out your power curve over the course of that one-day life cycle. So the more steady that the power curve is, the more stable the grid can operate, and the more the power plants are able to operate in their most efficient condition. Ford also just announced that the future software upgrade for the F-150 Lightning will not only allow it to power your house in the event of a power outage, but you'll also have the ability to power your house at peak electrical demand times. So if your utility rates spike at a certain time of the day, if you have time of day billing, you'd be able to switch over and run your house off of the car during those times. And then when when you get your off-peak hours and electricity is really cheap, then you have the car charge back up afterward. So, you know, it'll take a while to see how these technologies play out, but you can see a lot of practical benefit to there being, a couple million really big batteries connected to the grid, which is already one of the strategies that's been promoted, kind of stabilize the grid using, wind and solar power, which, is not always going to align with when we need the power. So having those batteries on the grid will actually help us make a better use of those resources.
So Bart, with that Ford F-150, am I just covering the basics in my house, or can I like run my dryer, things like that?
So that's a great question, and it really all depends on how long you'd want to run off of it. So they have a pretty giant battery, so it's a 100 kilowatt hour battery. Your house, I think, is typically going to average 1 to 2 kilowatts over the course of a year. But you could have peaks that could be 5 or 10. So if it's a really hot day and you got your AC blasting, I would not recommend that you also run the dryer and the oven all at the same time, or you're going to have a dead truck out there pretty quickly. But as long as you do some sensible load shedding, it could last potentially for days.
So DJ, how about your perspective on the EVs?
Yeah, I'll touch on from the consumer's point of view for owning EV cars. So one disadvantage is the charging time. Today, the fastest EV car charging station available today will take up to 30 minutes to fully charge a car, while it only takes a couple of minutes to refuel a gas car. Another challenge with the electrical vehicle is the amount of charging stations that's available today, which we're trying to solve here. But currently there's approximately 120,000 EV charging stations in the US, while there's more than 1.2 million fuel pumps in the US. So that is another challenge with owning an EV. On the plus side, one of the major advantages of owning an EV is the cost of refueling. The average cost of electricity in the US is approximately 12 cents per kilowatt hour today, while the average cost of gas is $3.15 per gallon. So for a person driving 15 miles per a year, it would cost that person approximately $550 to charge a car, while the same person would spend $1,900 to refuel a gas-driven car. So we're not talking about, we're talking about over $1,300, which is not an insignificant amount.
So we have our first question here in the chat. I share it with you. So what are the expectations for electrifying the commercial fleet, and how do the infrastructure demands compare? And if you wanted to address that now, or.
So I know some of the infrastructure demands, we actually have, I think, a slide that touches on a little bit later. As far as, people are doing it. I just had a conversation with one of our contacts at Pepco. They are in the process of electrifying their whole fleet. And I think they plan to have all of their vehicles electrified by 2027-ish, I think was the number that he said. So fleets do add a whole new set of challenges, but the fundamentals of it is still really the same. And there are a lot of benefits to fleets changing over. So we do expect that to happen sooner than later.
So DJ, to come back to something that you said, you talked about the different charging stations. And what are the different levels, the levels 1, 2, and 3?
Okay, yeah, we can touch on that. The first one is just your standard level 1 charger, which is simply charging from a standard 120 volt outlet that you would find in your home or commercial building. The level 1 charger gives you about 45 miles of driving range per an hour of charge, or it would take 24 to 36 hours to fully charge a car. Because of that extended time it takes to charge a car, we do not recommend level 1 and only see it viable as an emergency use only. And then you have level 2, which is considerably faster charge time than the level 1. And level 2 does require a dedicated circuit to be run, a 240 volt for residential, 280 volt for commercial buildings. And the level 2 provides about 15 to 40 miles of driving range per 1 hour of charge time, or 8 to 12 hours to fully charge a car. So based on that, level 2 chargers would be ideal for office building, for some fleet application, and hotels. which can accept extended period of charge time. And then there's level 3, which is also known as DC fast charging or supercharging. And as of today, that's what provides the fastest charge time. Level 3 requires a 480 volt connection, which gets converted from AC to DC current, allowing for a much rapid charge time. Because of the high consumption rate and that AC-DC conversion, the only issue with level 3 is it requires additional electrical infrastructure, including switchboard, transformers, and power units that needs to be located near the charging stations. And level 3 comes in different sizes, ranging from 50 kW all the way to 350 kW, and can provide full charge in less than 30 minutes. Because of that fast charging capabilities, these type of chargers can generally be found in retail, office buildings, and some fleet applications where quick charge time is essential.
We have another question here. What, in your opinion, is the best residential EV charging station?
So what I have, I just have a 240 volt, 40 amp plug. So it's essentially, it's the same plug that you have as a dryer plug. And that's just outside the house. And I can plug in to that with the stuff that is provided. If you are looking for a multifamily residential, it is going to be a slightly different answer. You would have the actual charging station there with the plug, with the cord on it. But that would still be a level 2. Might be a 50 amp. Anywhere from 30 to 50 amps is where those sit. So you might go a little bit bigger, but in general, you're still looking at that level 2, 240 volts power supply, because you've got overnight to charge typically.
Yeah, I would agree with that. With level 1, like I said, I mean, it can take up to 36 hours to charge a car. So, like I said, those are really for emergency use more than anything else, I would think.
DJ, what about the breaker sizes, the typical breaker sizes for the different levels?
Okay, yeah, that's actually a good question, Julie, because it differs from level 1 to level 3. For level 1, like I said, it's just a standard outlet, so it's just your standard 20 amp breaker that you have in your house. For level 2, it's a 40 amp 2-pole. Rarely we've seen an 80 amp 2-pole, but it's generally a 40 amp 2-pole. So it's twice the size of your level 1 breaker, and it's a 40 amp as opposed to 20 amp. But both of these, for level 1 and level 2, you can fit them in a standard panel. Now, when you go to level 3, because of the size I was discussing earlier, they come from 50 to all the way to 350 kW. The breaker required is, from anywhere from 100 amp all the way to 600 amp. So we're talking about large breakers, which will not fit in your standard panel. And so you need to install a switchboard just for those breakers. So that's why we talk about, when it comes to level 3, it requires a lot more planning than just your level 1 and level 2s.
Have you ever seen a level 3 charger used in a house?
I have not, and I don't think you'll see those. You might see those in a multifamily where they have a 3-phase service, right? But in a single family home, since you only have a single phase service, you're charging, the max you can get, it will be a level 2 charging station.
Got it.
Yeah, and I would say also, so my house has a decent electrical panel. It's a 200 amp at 240 volt. And even that whole entire panel isn't going to get you to that lowest threshold on that fast charger. And these are like orders of magnitude bigger than what you're looking at in a standard home. So that 350 kilowatts, like 600 amps at 480, that's going to be,
and that's at 480, right? Your building only has a 240 volt. So if you were to do it at 240, we're talking about, a 1300 amp breaker.
Yeah.
So DJ, how about the main providers for charging stations? Who are they? And do you see any of them chasing a particular niche in the market?
So, some of the big ones are, the ChargePoint, EVgo, Electrify America. Some of those are our clients, and what we see a lot of them is they're working with on the retail side. They are working with the retail owners. They can walk up to them and say, you know what, we can install a charging station on your facility, and we can guarantee more foot traffic in your business. While people are trying to charge their car for 20, 30 minutes, they will be walking around in the business, spending money. So we see a lot of that. We see them working with the manufacturers, car manufacturers directly. So that almost all of them, that's what they're doing right now. I can see that pivoting a little bit more toward the fleet application as you have more and more electrical fleet trucks, vans are becoming more available. Right now, the market is just not there. So that is not a big market for them just yet.
Julie, I wanted to touch on Dan's question here about the charger type. It's going to depend on what it's for. If it's for your own and you're planning on getting a Tesla, you'd be better off putting in the Tesla one. If it's going to be for your building's parking garage, I would go juice box. It's more vendor agnostic, and anybody can put an adapter on the the SAJ1772 plug that is standard for that the level 2 chargers.
Okay, and then could we mention the suppliers of the chargers again?
ChargePoint, EVgo, Electrify America, those are probably the biggest one. I mean, there's quite a few of them out there.
Okay. And probably more coming, right?
Yes.
With all of this,
all
these cars.
And we will have images of the chargers.
Yes.
Plugs, yeah.
So let's talk a little bit about space. So how much space do we need inside and outside of the building for the chargers?
Well, the amount of space needed for EV stations is really not dependent on whether it's installed inside a parking garage or outside in a parking lot, but obviously on the number of charging stations to be installed, plus the type of chargers and the required electrical infrastructure and the depth of the parking space, which I'll touch on shortly. We have a rendering here that we created for one of our clients that has 3 level 3 dual charging stations. In this scenario, we had to bring in a new electrical service. So we had to find a location for the transformer, which is located in the island there. And then just above the transformer is the switchboard. In this one, like I said, we had 3 charging stations. The switchboard was about 6 feet wide. Now, for every 3 to 4 charging stations that's added, this switchboard, the equipment would grow probably by another 3 feet or so. And then right next to the switchboard is the power unit that serves the charger. This is where the AC to DC conversion occurs that I was talking about earlier. And most level 3 chargers do require this power unit. In this case, only one of them did. And these power units are 3.5 by 2.5. 3.5 feet by 2.5 feet. So as you add more chargers, you can see how much the infrastructure will start eating up a lot of real estate. And as for the chargers themselves, they are roughly 2 feet wide by 15-inch deep. And ideally, you would want these to be installed in front of a parking spot, in between parking spots, so 2 cars can share it. But that is only if the parking space is deep enough or there's space in front of the parking spot. But that's not the case in most parking lots, right? So, what we would do is we would stripe the parking area and locate chargers in between the parking spaces. And because there will be some parking spaces that would be lost. In this project here, we lost 2 parking spaces to accommodate the 3 chargers, and we were able to provide 1 ADA compliant charging station. So the amount of space needed would be very site specific and depend on the number of chargers to be installed and the actual existing physical condition of the site itself. Here, we've been talking about level 3 only, but if we were to just do level 2, you can assume you'll have only one electrical equipment, and it will be about half the size of the switchboard that we were showing there earlier. And the chargers themselves will be about half the size of a level 3. And usually you should, you'll be able to fit those in front of a parking spot and don't have to eat up any parking spaces.
I have I have two questions here that I wanted to touch on, Julie, if you don't mind.
Sure. Yeah, of course.
Is it more cost effective and practical to charge an EV at home or a commercial charging station? So from a cost effectiveness perspective, unless the charging station is being provided as a free amenity from the building, it will be more cost effective to charge at home. You're paying that straight residential rate instead of, you know, a markup on that rate. Obviously, if you can charge for free, that's obviously going to be your cheapest thing. And then the other question was, in our opinion, what's the best residential EV charging station on the market? And I actually think that that depends on what car you have, because different cars are going to come with different charging accessories, and it's what charger is going to work best with your vehicle with the least amount of extra stuff. So, you know, the Tesla has its own specific plug. So for me, the best one would be a Tesla charger, because then I don't need extra stuff. You know, if you've got, you know, I don't know actually, honestly, what the Leaf comes with for charging, but it definitely comes with something, and whatever, you know, that thing is that interacts, you know, I don't think they come with their own charger. Like, they don't have a box you put on the wall or anything like that. So from a personal perspective, you got to kind of figure out which car you're going to get, and then you're going to pick the charger. But either way, you can do the infrastructure up front. You're always going to need 240 volt. You're always going to need a minimum of 30 amps. And then from there, it's just which one is actually best for the particular vehicle that you're getting.
So Bart, you talked a little bit, I mean, you just referenced the plugs. So DJ, could you talk us through those, the different charging plug types?
Yeah, sure. So level 1, like I said earlier, standard outlet. So not much else to say about that. Level 2, Bart just touched on that. It's pretty much been standardized by all the manufacturers, the J1772, except for Tesla, who have their own plug. Now, when you get to level 3, there are 3 types of plugs. Again, Tesla has created their own, that they call the Tesla supercharger. The other 2 are called the CHAdeMO and the SAE combo, or CCS. The CCS, the most common type currently used by the US, European, and most Asian manufacturers, while the CHAdeMO is limited to a very few Asian manufacturers, including the Nissan Leaf that you mentioned earlier, Julie.
So then I'd love to hear from both of you on this next question. What are the logistical requirements that building owners should think about if they're installing charging stations?
Okay, I'll start on that one. So some of the challenges, you know, you want to consider when planning to install charging stations are ADA accommodation, some zoning, and obviously power availability. Regarding ADA, based on the local permit office requirement and the number of charging stations that's to be installed, some of the charging stations may need to be ADA compliant and need to be installed in an ADA accessible space with all the appropriate, you know, reach range and turning radius. And these spaces also may need to be located in an accessible path into the building from a parking spot, so that may require additional curb cuts and ramps. Regarding ADA, for example, we just finished a major renovation project where we were also adding some EV stations, and the county came back to us and said, you know what, for every 6 you put in, 1 needs to be ADA accessible. So this is something that should, you know, be investigated early in the planning phase. Another item to consider, like I said, is the available power. If the intent is to install just level 2 charging stations, in most commercial building, there should be enough spare capacity in the electrical system to install 1 or 2 charging stations and serve them from the existing electrical service without a problem. But if the intent is to install level 3 charging stations, because of the high electrical draw we discussed earlier, a detailed investigation of the electrical system would need to be conducted to determine the available spare capacity. Depending on the quantity of chargers to be installed and the available spare capacity in the existing electrical service, it may be required to provide a new electrical service. And in fact, we see that happening a lot on most projects. In addition, as I stated previously, because of the additional equipment required for level 3, an equipment yard will need to be allocated in the vicinity of the charging stations, which may take away parking spaces, which could affect the required parking count for the facility, hence some zoning issue that may come up that needs to be looked at initially.
What about, so we have another question. Is there a potential for efficiencies in technology to reduce the size of electrical equipment required for those level 3 charging stations, similar to what happened with the personal computer?
You know, I unfortunately I don't think so. A lot of that stuff is just driven by straight fundamentals of electricity. You know, your physics 2 class, you need a certain amount of copper windings, you know, a certain number of windings to transform this amount of power to this amount of power. And there's just fundamental limitations there that's going to be a challenge to make those significantly smaller. So utility transformer is the utility transformer. It's really not going to shrink too dramatically. Every now and then there's talks about potential changes in transformer technology. But I've never seen one that really made things fundamentally smaller. And, you know, similarly on the power panel, you know, you're pumping 600 amps through that thing. You need this much copper, or else it's all going to just catch on fire. Mm-hmm. And, you know, the amount of power that we can get through one piece of copper is really not going to change, I don't think, either, unless we start upping the voltage. You know, going to, you know, some medium voltage crazy thing, which probably could be in the cards. I think if you were going to wanted to do fast charging for, you know, 100 spots at a mall, you know, maybe you're doing some medium voltage distribution. You know, maybe they can develop some medium voltage power units. So
yeah,
maybe
I can really see that happening, because we worked on a project where we put in, I want to say, like 50 level 3 charging stations, and you know, we brought in medium voltage electrical service because of just the amount of power that was required. Now, if they had the power units that convert, you know, from AC to DC instead of 480 to, you know, 1000 volt DC, if they had a power unit that did the medium voltage, then we would have eliminated a lot of transformers, a lot of switchboards. So I can see, as the fleet market grows, that could be a possibility. I can see that happening myself.
That'd be pretty cool. So that's really going to be on the power unit manufacturers to kind of take that next step and develop, you know, a 13,000 volt in, 1000 volt DC out kind of thing. And then that'll allow us to shrink the wires coming in. Depending on what your utility has there, maybe you don't have a utility transformer there at all. You're just going right through a meter socket and bringing that medium voltage right out to the power distribution units. Cool. I like it.
What about safety issues to keep in mind for both the chargers or the car batteries? Yeah, so there's a little bit of regulatory uncertainty, for lack of a better term there, around really it's all about the indoor charging. You know, outdoor, you know, I don't think too many people have significant concerns, because if things catch on fire, they just burn, and that's that. You don't have to worry about it burning down a building. So inside the building, we're worried about NFPA, we're worried about FM Global, we're worried about IBC, and all of those things have the capacity to change. They change, you know, every couple of years. So I have confirmed with our code consultants that NFPA still has not done anything to specifically address indoor car charging. So we don't have any rules on car spacing. We don't have any rules on exhaust. We don't have any rules on sprinkler coverage. The reason why I bring that up is so the UPS industry has been using large indoor lithium batteries for several years, and NFPA does have specific rules about how they are spaced, so that if one of them catches on fire, it doesn't catch all of the other ones on fire down the road. So it's not far-fetched to think that NFPA or FM Global
might move to require 6 feet of space in between electric cars that are charging indoors. So there's not really anything that we can do about that right now. We just kind of have to wait and react to that, but it is something to think about if you're looking at a large indoor level 3 application in particular.
Okay. And then Bart, anything else that you wanted to add about the logistical requirements?
You know, someone's got to pay for it. So if you're lucky enough to get a grant from the feds or you know, a rebate program, that can go a really long way. And there are other, you know, funding sources that are available
Okay.
to work
Good.
out.
Another question here, does the weather impact charging stations?
So we've worked on, like you said earlier, on projects all around the country, all around North America, you know, anywhere. We put some in the deserts of Arizona, all the way up north into Canada, and we've never heard of any issues. So, you know, looking at the spec on these equipment, their operation range temperature-wise is pretty wide. So we have not run into an issue. We have not seen any issue at all on any of them.
Okay. Okay. So Bart, you talked a little bit about, or let's talk a little bit about the cost of installing the charging stations. Talked about that. Let's think about the other side of the coin, right? Are there financial benefits of having charging stations on your site? And is there the potential for them to be a revenue generator?
Yeah, definitely. So one thing that always helps, you know, the more you can get those incentives or, you know, grant programs and offset those first costs, obviously that's going to be huge for impacting your ROI and making that return a lot more, lot faster. Aside from that, we actually, you know, there is an opportunity for direct revenue, depending on the style of charger, and if you're trying to use it as an amenity, that you do charge, you know, pay to use them. So those rates are significantly higher, up to a 200% markup over, you know, that retail electric cost. So there is a direct revenue potential there. And then there's the indirect revenue potential. And I think DJ touched on it a little bit earlier. But the car charging stations create foot traffic, and they create a need to kill time. So all of those are good for indirect revenue, but they can also be a competitive advantage for people who want to attract EV drivers to stay at their hotel or lease their office building instead of a competitors who does not have the charging capabilities there. And that actually is one where we do see or expect to see an increase in demand. You know, you have a lot of people who may want to have an EV, but just don't have anywhere to charge it. They live in a multifamily house. They live in a townhouse area that doesn't have dedicated parking. You know, you're parking on the street and there's no chargers out there. Being guaranteed a charging station at work could be a real differentiator and really what makes that feasible for them. So we have not really seen it written into leases yet, but we do expect to see the requests for charging stations in letters of intent really, and then once it starts, I expect that to continue to grow quickly. Just no one wants to be the first one. And then last, you know, we mentioned fleets earlier. Fleet operators see not only a reduction in fuel prices, but then they have the ability to control the fuel source, be able to fuel up, you know, in their yard versus dealing with gas cards and all of the headache that goes with those trucks needing to be charged, you know, refueled on the road.
What about demand charges?
You know, typically not. In most commercial buildings, the increase in demand from a couple level 2 chargers is not going to have a noticeable impact on the bill. Where you would see the impact is, you know, you have dedicated service for your level 3 chargers, and those are going to spike up very high very quickly. Again, you know, that's its own service, so those demand charges are lumped in, and they're you know, built into the costs of using those chargers.
Do you think that building owners could think about these charging stations as a building amenity?
Oh, definitely. Our building, I just discovered, they do offer the charging as a free amenity. And I think some of our landlord clients in Arlington, I also recently learned you don't have to pay to use any of those charging stations. So that is there purely as a building amenity. Now, I think in the long term, that's going to have to change. I think once demand goes up, it will start to be a financial burden at some point. Right now, it's a rounding error on utility bills. But as adoption increases, it could become a more significant impact, and they'll kind of be forced to start charging for it.
What have you seen as far as incentives?
So I can really speak to what Maryland is doing right now. I'm personally in our Rockville office. Maryland's offering a 40% rebate on charging equipment and installation. So I think it's capped at $4,000 or $5,000 depending on the application. So that's just the one I'm most familiar with. But if anybody has any particular states or locations that they're interested in, let us know and we can find out.
And we have another question here. So how do you prevent cars from parking at charging stations well beyond their recharging period needed? Good question, right?
I think I could speak to them in some ways. So a lot of them will charge a time fee. So if your car is done charging and you stay plugged in there, they will start charging you just for taking up the spot.
Oh, interesting. Okay.
There's definitely cases of people who presumably think that they're funny, intentionally blocking electric car spots.
Yeah.
But you just get them towed, and then it's the laughing happens the other way, and everybody.
So then, Bart, we do have a couple of requests as well about incentives for Virginia.
Okay.
So if you want to follow up with that information to the folks that posted those questions.
I will say Virginia in general is not as gung-ho about incentives, utility incentives in general. There were not any available when I put in mine, but I can definitely see if that's current. I'll do a little digging on that.
Okay, great. Okay, so DJ, if a building owner has decided to install electric vehicle chargers, where should they start?
Well, here at WB, we work on a lot of EV projects, and on most all of them, we're involved from the onset of the project with coordinating and educating the permit and the utility officials all the way to commissioning at the end, and obviously everything in between. But we would generally start every project with a feasibility study. Just to emphasize again, you should never assume that the building infrastructure or utility service can support the new chargers. So, we would first evaluate the existing electrical service to determine what level of chargers and quantity is feasible, utilizing the existing electrical service. And if new electrical service or service upgrade is required, then we would start communicating with the local utility company to determine what level of electrical service would be available for us. We'd also start investigating the local permit office requirements and looking at the layout of the existing parking lot to finalize the quantity of chargers that would be feasible on the site. So, and based on that information, we can communicate, we can recommend the type and quantity of charging stations that can be installed on the site. On the study, we would also include a ROM cost estimate, so the client will have an idea of what their financial commitment will be. Bart, why don't you talk about the next step once we know the feasibility of the site?
Yeah, happy to. So, once we've figured out a feasible program, the process then goes on, a lot like any other construction process. You get to go design, bid, build. You can go design, build. There are several groups, us included, who can provide complete turnkey solutions for you. The ideal solution is going to depend on what you're doing, really. So installing a small amount of level 2 chargers is a very straightforward process. Growing number of groups can give you a solid lump sum fee to do that work, just based on, a narrative and a sketch. Once you start talking about fleet applications, level 3 installations, we do recommend some level of engineering design before you go out for pricing, just to make sure you're able to get competitive apples to apples pricing. Either of those solutions, once you get past 1 or 2 level 2 chargers, you're going to need permit drawings, you're going to need site plans and zoning approvals from your local permitting authority. 1 or 2, level 2s, that's something that, electrician would pull a trade permit for, and typically would not require a whole lot of drawings for.
So,
Question.
yeah. So DJ, we mentioned at the beginning 3,500 of these charging stations. So you have a lot of lessons learned, a lot of stories, right? Any particularly memorable projects?
Well, the one that pops up always first is, and it may be because it was the first project we did and we ran into an issue. It might be that, but so on that project, we were still in the design phase. When we were still in the design phase, the manufacturer of the charging stations was also in the final phase of designing their equipment and manufacturing it. So they weren't able to give us the specifics on the equipment. So we continued with the design. Once we were done with the design and had moved on to construction, the equipment got delivered on site with much lower available fault current withstanding than what is generally seen in electrical equipment of that size. Just so you know, the fault current withstanding of electrical equipment is the amount of fault current an equipment can withstand if there's a fault in the system before the equipment causes any shock or fire hazard. So with the equipment now on site, we had to come up with a creative solution without affecting the size of the mechanical yard. So the solution was to add these electrical reactors, which look like kind of like the transformers, to be wired ahead of the charging stations, the chargers themselves, so it can choke any fault current that comes in and limit the amount of fault current the chargers would actually see. But again, the hard part was to make sure that mechanical yard didn't grow, which was essential for the client. So we had to build a structural frame and stack the reactors, and we were able to do that again without making the mechanical yard grow. Thankfully, that's no longer an issue because all the manufacturers now are making equipment with that proper withstanding. But it was still a good lesson learned for us on how important it was, trying to keep that mechanical yard as small as it is, and you're not eating up on parking spaces.
So we have another question here regarding the residential installations. How do you protect power connection from power fluctuations? A breaker panel will help, but is there anything else you can do to protect? Or is that built into the car?
So that's a good question. I think that it is built in. I sure hope it's built into the car. I know they didn't recommend I install any surge protection devices or anything like that. I think that there's so much mass there. The battery itself weighs like 1,000 pounds. I think there's just a lot of mass to absorb things. And I don't think any surge that you're going to get from your utility is going to be any worse than, what it sees driving, which is probably pretty brutal on the batteries. I got 2 other questions. Just general one on the economics of installing car charging stations for a landlord. And it's not an easy answer because there are a couple things to think about up front. It's a conversation that needs to be had with the brokers. Is there a demand in that area? The demand is not growing evenly across the country. You're seeing spikes in certain areas. So if you're an area that has low demand, unless you specifically want to be at the front of the movement, there's not going to be as much of a return. But if your brokers tell you, hey, people are starting to ask this question, if you're just looking at a couple level 2 chargers, the cost for that can likely be built into, the cost of a lease. If you have a new tenant who's going to come and, take a large portion of the building, you're going to give them a TI allowance, and that's baked into the lease. We also factor in those costs to put in a couple level 2 charging stations for, their people who need them. And then there's the idea of, again, of it being an amenity. Is how much is it worth it to, attract other people, show that you care, that you're being part of that, charging development. It's a little hard for us to certainly put dollars to off the top of my head. But those are the types of things that you need to factor in when you're looking at, your capital outlay over here and your potential revenue increases over here, and how much of it's just marketing. If you have a lead building, it makes a whole lot of sense to continue telling that story with car charging stations. Whereas if you don't have a lead building, maybe that's either a way to try and push the building in that way, or maybe it's not the right application for that building. There was also an interesting question on in older neighborhoods, DJ, could you be limited per household or street on permanent EV chargers?
On the residential side?
Yeah.
No, because well, in the older house, if you have some of the older houses only have 100 amps electrical service. So if you have a 100 amp service and you are putting in a 40 amp load on it, all of a sudden, then that is something you might want to look at before you do anything. But most houses do have 200 amps service in them, so you should be able to absorb that 40 amps without any issue. On the utility side, from the power company's aspect, with all the electrons that's flowing into their system, a 40 amp that's added is really not going to be any effect on the utility services.
I would think that if the neighborhood decides to go in and add 50 of these things, and it's an extra 2,000 amps, if the utility has to add an extra wire, I don't know. That's their job, right?
When you get to that point, the utility company is always monitoring what the consumption is for that neighborhood, right? So if they start seeing something, then yeah, they are going to have to upgrade the service that's coming into that neighborhood.
And you've never heard of anything where a utility, proactively tells people that they're limited on it, have you?
No, we have not heard that, no.
Great. All right. So any other questions, if you want to drop them in the chat or the Q&A. So I think, Bart, I just have one last question for you here. What is your favorite thing about your EV?
Well, I actually think the thing I like the most, is probably going to sound a little weird, it's I can turn on the HVAC remotely, and I just have a little heat pump compressor running without having, the big gas engine running. I used to drive a black car with a black interior, and I would get into it and it's 150 degrees and it would just never cool down. My back is hot the entire time I'm driving home. And being able to get into a nice cool car.
So we love the Byron, thank you for your message. It's really nice. It's great. And we're so happy that you love working with Jimmy Sneed. He's great. So thank you for that. So just wanted to thank everybody for joining us today. So we recorded this. We're going to post it on our YouTube channel, and Bart and DJ, their contact information is here. They love this subject. They love to talk about this. So if anybody has any additional questions, please let us know. And again, thanks for your time, and thank you, Bart and DJ.